In this lesson, we're going to talk about how to control splines. Open a blank part and open a sketch on any plane. We've already talked about how to place spline points, but let's talk about it in some more detail and add some aspects of control. Splines have to have at least 2 points. So you can have a beginning point and an end point. And that last point was achieved by double-clicking. If you just have a 2-point spline, it looks like a straight line. But if you use the handles, you can get an S shape out of the spline. Shape can also be achieved by having tangency to other items within the sketch, as we've already mentioned before. The other controls that are available for splines are going to be available from the right mouse button menu. So if you right-click on a spline, we have controls such as Add Tangency Control, which is essentially just one of these handles. SOLIDWORKS adds a control point to the spline, and you automatically get a handle that way. Add Curvature Control allows you to place a control on the spline itself, and then by clicking on the control, you can change the radius of curvature of the spline at that point. Other controls include insert a spline point. So if you've got just a couple of spline points, you can add a spline point and make changes based on that. Or you can delete spline points. Another control is to hide or show the spline handles. Spline handles are usually shown when you select the spline or if you change the value of the handle. Display the control polygon is an option that you can use to control the spline via an alternate method. Some people find that they prefer this over using handles and points on the spline. Show inflection points is an important one if you are interested in seeing if the spline flips convexity at all. In this area, the spline is concave up, and here it's concave down. The point at which that flips is indicated by the bow tie symbol. Show minimum radius is an important tool as well, especially if you're trying to improve the ability of a model to be shelled or offset or any one of a number of other conditions that can happen because of having an area of tight curvature. You might not be able to see it, but this is showing a pale yellow circle that corresponds to the point of the tightest curvature on the spline. If we were to add a couple of spline points here, we can edit this to make a tighter curvature, and it's indicated with the radius value and again this pale yellow curvature icon. The curvature comb is another visual aid that enables you to comparatively see areas of tight curvature or areas of loose curvature. Curvature is equal to 1 over the radius. So if you have a very large radius in an area like this, it means you have a very slow curve or very open shape. So a very high radius would give you a very low curvature. In a spot like this, you have a small radius, which gives you a high curvature. The radius and the curvature have to be understood as inverses of one another, and the curvature comb is very tall in an area where the radius is very small. These are the tools that we generally use to help us evaluate splines, which in turn will help us troubleshoot geometry problems down the road.